All right. So today we're going to talk a little bit about metallurgy and like the metallurgical process. And this class is really kind of dealing with a little bit of metallurgy, even though we may not really talk about it in like the scientific terms. There's a lot of stuff that we've discussed in this class so far that really kind of deals with the properties of metal. So, what is metallurgy? Okay, so metallurgy is the science and technology of extracting, refining, and preparing metal for use. It's also the study of the composition, structure, and its properties that kind of pertain it. We use a lot of these things in the welding process. Like, can it withstand like electricity, or can it conduct electricity? How does that stuff work? The different types of metal. Everything we've welded on in this class is mild steel, but sometimes we need to understand, like, is it stainless steel? Is it aluminum? And what kind of alloys do we mix in with those things? What other kind of elements and chemicals do we mix in? That all affects the process and how we weld. And certain processes, are better suited for different types of metal. And so depending on what we're doing is going to kind of determine that. So understanding, how we kind of get these things, what the structure, what it's made out of is really important to the welding process to actually understand what's happening rather than just we're just welding straight up. You need to understand those things there. So when we think about metal, and this is not something that a lot of us see, but basically metal is inside of rocks. We call it ore when we first mine that rock. We mine that rock. We get that ore. There's different elements that are made up within that. We then go through a processing where we crush that ore. We extract those elements from that rock, and then we take those metals and we do different things from it. Iron ore is probably the most common one that we deal with. Anything that is going to be any kind of steel is going to use iron ore as its base component. There are other things that are mixed in with that to make the different types of steels that we use, but iron ore is the base part of that stuff. So when we think about steel, there is always going to be iron in it. When we think about things that are metals, because it's not just a mild steel that we use, but things that are metals are going to contain most of these following elements. One, it's going to be solid at room temperature. So if we're at room temperature, which is I think like 75 degrees, somewhere around there, that metal is going to be solid. There are some metals that take this and actually are not solid at a room temperature. Some things that you can kind of think of, which I don't think they use this as much today as they used to, but mercury we used to use in thermometers. And that mercury is a metal, but is at room temperature, it is a liquid, so it has a very, very low melting point. And so we put it in a thermometer, and so as the temperature increases, that metal is going to expand and contract. And as you can kind of see, those other two, all metals, not all metals, but most metals are going to expand when heated, and they're going to contract when cooled. And so use those properties of metals to actually make thermometers. Nowadays, I think they're using some other stuff because mercury can be kind of poisonous. Gallium is another metal that is not a solid at room temperature. It is, kind of similar to mercury in a way, but it's got a little bit more, um, it's got a higher melting point than mercury does. So we don't use those things in thermometers and never have. But gallium is another example. There's probably some other ones. Those are just the two that kind of come into my mind. One of the biggest properties that we take advantage of is that it conducts heat and electricity um, very, very well. So it allows electrons to basically move freely. And any kind of the processes, the MIG welding, the sheet metal arc welding, if we're doing TIG welding, those things are all going to use the property of the electrical conductivity of that to actually use to heat up the metal to actually cause the melting. Most metals are made up of tiny, tiny crystals. We've got a picture that's going to show you kind of what a close-up microscopic view of what metal actually looks like. Um, they are also going to a lot of times reflect light when polished. So if you polish it up, it will reflect light, almost be like a mirror finish. Think of like a stainless steel that's been polished up real nice. It'll do that. Even mild steel, the steel that we've been working with, you can actually shine that stuff up if you polish it enough. And then the last one that metals, the last property that metals kind of have is that they are opaque. Opaque means that you cannot see through them. So it's kind of clear, it's kind of cloudy kind of look. And a lot of metals, we can't do that. I don't know if there's a metal that is not opaque. I'm kind of curious. So now I'm going to probably look it up. But opaque means that we can't see through it. And most metals fall into most of these properties. There are some exceptions of those. So this is kind of a microscopic view of what we see on a piece of metal. Even a metal like this one, from our point of view, this metal is actually going to appear like really, really flat. So if you look on this edge right here, it looks very jagged. And that is how metal looks. Even a nice clean cut is going to have jagged edges to that. And so when we're melting things, we're melting those crystals down. We're joining them in with other base material that is similar to it. And then we're basically creating a nice little structure that is as strong, if not stronger, than the base material that we're actually welding on. But it does have pores. When we get into like braze welding, we're not actually doing a melting of the metal. We're just heating up that metal. And then there's other lower temperature metal that's actually going into the pores of the metal, because even though it may appear flat, it's not going to be flat. If you've taken a chemistry class, you have probably seen this periodic table of elements. This is just kind of, I kind of throw this in there just so we can kind of see some of the things. We use some of these gases, when we're welding. Like we might use like a helium, we might use a nitrogen, we might use carbon dioxide, which is going to be a mixture. That's not its own thing. Sometimes we even add oxygen in. We might use a combination of gases. And gases we can find over on this left-hand side. Really, when we kind of think about the metals, the things that we're kind of dealing with is going to be in this kind of center stuff. And you can see this one's nice and color-coded, where we have like transition metals, basic metals, semi-metals, so some things that are metals, but then they're not, because they maybe have more or less of those properties there. So when we look at, this right here, this is kind of where we see things like aluminum. We see things like tin, zinc, copper, nickel, cobalt, iron, which is labeled as Fe. That's like the most popular one that we are using in a welding class, is that. Golds, you see other things that are kind of within there. So we're taking these base elements, we're combining these things together to create what we call an alloy. And an alloy is a combination of multiple elements to help create what we want. Bronze is kind of one of the first alloys that we really kind of came up with. If you know kind of history, we had this thing called the Bronze Age, when we figured out that we could actually mix copper, tin, lead, silver, and other metals together to create these different weapons or shields as we went through. We used to have an age where we found copper, and we would make weapons out of copper. Copper is very malleable. It doesn't hold its shape as well. And so when we figured out that we can combine that in with other materials and create a stronger material, those countries that had that ability to do that dominated, because they had weapons that didn't bend or weren't as malleable. They had better shields that could withstand attacks from other people. And so, mixing of these metals really has a huge part in history of putting them together. It's not a pure metal element when we mix them, so it is a combination, of those things. We essentially melt them down, we add stuff together, and then we get different characteristics within those things. Alloys that we kind of see today is going to be steel. Steel is going to have a carbon content within that, and so when we talk about like a mild steel, we're going to have the main component is going to be iron, but then we mix iron with carbon. And when we mix that with carbon, we get different types of steels. So we have mild steels, which are probably the most common that we see, but then we also have tool steels. Tool steels add a little bit more carbon into that mixture. And we're talking, I think mild steel has like a 0.03% carbon. There's not much carbon in it at all. But as we start adding more and more carbon, we start getting stronger and stronger materials. So when we think about like cast irons, okay, cast irons actually have more carbon than steel. They're very, very hard. But as we start adding that carbon in, it starts to become more brittle. So tool steels are kind of a mix between a mild steel and a cast iron, where it increases the strength but doesn't decrease it and make it more brittle. And then we have stainless steels that we can mix in where they're stainless steels are going to use like a steel where we have iron and carbon, and then they're going to add other things into it to help increase its strength or change its properties, make it more resistant to corrosion. That's kind of the biggest thing that we do. There are different types of stainless steels that we deal with. We have 304 stainless steel, which has about 18% chromium, 8% nickel, and the rest of it's going to be a steel base, so iron and carbon mixed in with that. We have 308 steel, a 316 stainless steel. Those things are going to have different properties where we see different, parts and pieces. And boilers, we see 308 and oven linings, things where we're going to have high heat. They're going to be very, very resistant to that. 304, 316, we see those a lot on like food processing stuff, things that are going to be in like other highly corrosive things where we might have like chemicals and stuff like that. We're going to use a 316 stainless. 316 is going to have chromium, nickel, molybdenum, along with iron and carbon mixed in with that stuff as well. So we're just mixing these things into different kind of components, and we're getting different types of materials. And over lots and lots of years and lots of testing and seeing what things work, we find, uses for the different mixtures that we have. But doing this stuff obviously, creates more work and process within that. And so prices of these things, stainless steel is typically more expensive than a mild steel because we're using a mild steel base and then adding these things into there. And so it's a little bit more on the process of that. When we think about metallurgy, there are really two types of metallurgy that we kind of deal with kind of on a day-to-day basis when we're welding and stuff. There's process metallurgy and physical metallurgy. Process metallurgy is a little bit more of how we take those products and make them into the structural plate or the bar stock or the square tubing that we are getting from the manufacturers that are doing that. So they're taking it from a raw material into the basic products. And we use those basic products as we're constructing things, putting things together. Stuff that we've used in this lab is just a flat stock of metal that had to be shaped into that. And so we're getting it from those things. Understanding what those different shapes are and how we kind of get to it isn't really critical in a welding class, but it's nice to understand a little bit of how that stuff is kind of made. Physical metallurgy deals with the composition of those metals. What happens to their structure when we're forming, when we're fabricating, when we're shaping. Some things that we've probably seen in this class is as we are tacking metal together, say a butt joint, you might have metal that's together. We might tack it, and that metal may separate a little bit. All metal is going to, move as we heat it up. Okay, it's one of those properties of metal that kind of helps define what a metal is. And so when we're fabricating something, that is still going to happen. So if we put something and we make it square, but we apply heat into that, all of a sudden things are going to move and it's no longer going to be square. And so we have to understand that process, understand that metal is going to expand. It's going to contract as it cools down. A lot of what we do is we dunk metal into quench tanks, right? We do that so it cools that metal down so we can handle it. But that also kind of changes the structure and the composition of it. It goes through what we call a tempering process, so it makes it harder, but it can also make that metal brittle, and so it can fracture a lot easier. When we're fabricating projects, very often we don't cool them down. We let it cool down naturally. We do what we call an annealing process, and we let it cool down, which makes it more malleable, resistant. If it's a trailer bouncing down the road, if we tempered that trailer, parts would not have a little bit of flex, and things would start cracking. And so annealing that stuff, letting it dry naturally within the air, sometimes we even pack it with sand to let it cool down even slower, can help change the structure of that metal. Even though we're not actually changing anything with it, we change the strengths with that metal by cooling it down, heating it up, going through those different processes. So how does it fit into these things? Okay, we do use both physical metallurgy and process metallurgy when we're heating and melting metal. Okay, it's kind of like steel making. We are taking a rod, we are adding materials in there. Ideally, most of the time we use the same base metal within that. If we're doing a fusion process weld, we are going through and actually changing that steel a little bit. But we're also using the physical stuff as we're doing metalworking, shaping, machining, rolling, changing those things into different shapes. We're also using those properties of metal and combining those things together. So we do a little bit of that. You don't have to have a huge understanding of how these things work, but a general basic understanding is important for somebody to really fully understand what's happening. So I mentioned fusion welding, okay, versus forge welding. Fusion welding is pretty much everything we've done in this class with the exception of braze welding. Braze welding, you are not melting parent material. You are simply heating it up, still using the properties of metal to then let another metal go into the pores of it, kind of like we have pores on our skin. We let metal melt into that, and that's what actually holds it. It's not going to be as strong as a fusion weld, but it is something that we can use to join dissimilar metals together. When we're doing a fusion, we're actually melting that parent material and allowing them to become the two surfaces to become one. You really should not be able to, if everything's done right, you shouldn't have any strength difference from parent material to weld to the other parent material. It should be a nice, seamless kind of transition between the two. That differs a little bit from forge welding. When we're forge welding, we're joining metal together by pressure. So we use heat to actually join them together, and a lot of times we'll have like power hammers and things. If you ever watched Forged in Fire or any other kind of blacksmith show, you might have seen that there's, they do a lot of fusion or a lot of forge welding where they smash these things together. Now, we're not creating enough heat. We're not actually melting it down into a liquid, but we heat it up, and then that forging process joins them together, but it's not a complete joint process. It's not necessarily as strong as the parent material. Even if we're doing things like Damascus steel, you can see up on the knife that we have right above, Damascus steel, we essentially just take that and we fold it. And then we stretch it and we fold it and smash it and forge weld it together. And we do this many, many times. And that's where you get this design built into that. So it's a really laborious process to go through that and do that. You can get really nice, looking designs in it. There is a lot of structure. There's a lot of strength. You're not going to be able to just snap that thing in half. But it's all those folds of that parent material over each other. But the reason you're getting those lines is because it's not a complete fusion weld like we've done in this class. It's a different process kind of altogether. And it's kind of like a dying art. We don't see a lot of forging done. Really where we see that today is on TV shows and actually farriers. So people that make horseshoes, they actually still do quite a bit of forging within that system. But this process is more of an art than it is a functional, because the fusion welding processes, the things that we've done in this class, are far superior to a forge welding where you can get strength, time, how much time it takes. It's a lot quicker for us to do that than it is to forge weld something. But there are still some uses and some things there in understanding forge welding. It's just not something that we're able to do in this class. So being able to weld does not require an extensive knowledge about metallurgy, but that basic understanding can help avoid making mistakes, things that are going to weaken the metal, understanding the different types of metal and what we can join together versus what we can't join together. Some steels, if they're close in their composition, can be joined together, and some things like aluminum can't be joined with like a mild steel. That's where we would use a braze welding, where we're not doing a fusion weld, but we can kind of join them together. You're just not going to get the strength with those things. Other than that, we would use things like bolts and other stuff to fasten things together. But if we can do some sort of welding process because we understand that, that can help us out a little bit.